In our previous lesson, we learned how to graph a line in standard form using the x and y intercept. Standard form is very useful for finding those 2 points so that we can graph the line. So let's say we have this linear equation. This is in standard form, and we wanted to find the 2 intercepts so that we could graph the line. So why don't you take a moment? I want you to find the x-intercept of the line, and I want you to find the y-intercept of the line. So the x-intercept, y is 0, so I solve 3x equals 19, and I get x is 19 thirds. That's 6 1/3, right? So the x-intercept is 6 1/3. It would be between 6 and 7, correct? The y-intercept, I let x be 0, 7y equals 19, and I get the y-intercept is 19 sevenths. That's 2 and 5 sevenths. That would be between 2 and 3 on the y-axis. Now, those are not difficult, but they wouldn't be very accurate, right? We are not going to find exactly where 6 and 1/3 is on the x-axis unless our graph was made to be more precise. We're not going to find exactly where 2 and 5 sevenths is on the y-axis unless we have that precise of a graph. So sometimes when we are looking at standard form, the x-intercept and the y-intercept are not pretty. They're not nice to work with. So we might want to do something else. Now, I've told you this is a linear equation, and it's a line, just like slope-intercept form is a line. So we're going to learn today how to convert from standard form to slope-intercept form, because sometimes slope-intercept form is easier to graph, okay? We did this early in the year when we did literal equations and all the equations had lots of variables in them. We did this and learned how to do this at that time. Now, that was a long time ago, and it's been a crazy year, so you may not remember this, but we've done this before, and I told you at the time, I said this is coming up later. This is why we're doing it now. So if I have 5x plus 4y equals 20, and I want to put that in slope-intercept form. Well, we know slope-intercept form is y equals mx plus b. So what we need to do to put this in slope-intercept form is we need to isolate y. That's going to be our goal, is to isolate y. So here's 4y. That means I need to move this 5x. So it's a positive 5x. I'm going to subtract 5x from both sides, and I get 4y equals negative 5x plus 20. Okay, now this is 4 times y, so my inverse operation is division. So I'm going to divide this by 4, and I also have to divide everything on the other side by 4. So divide every single term by 4. So that those 4's cancel, and I get y equals, this is negative 5 over 4, so it's negative 5/4 x. And then 20 over 4, this is plus 5. Okay, so this is slope-intercept form. I now know the slope. I know the y-intercept. I could graph this if I wanted to from slope-intercept form. So let's convert and graph. Okay, so this is 2x plus y equals 5, and I want to put this in slope-intercept form, which means I want to isolate y. So I'm going to leave my y alone. I need to move this positive 2x. I'm going to subtract 2x from both sides. Do y equals, write your term with the x in it first so that it looks like slope-intercept form, and then plus 5 at the back. Now, this is already isolated, right? This is 1y, so I'm done here. So I have y equals negative 2x plus 5. My slope is negative 2 over 1, and my y-intercept is 5. So you'll recall we put the y-intercept on the y-axis, so we put a point on the y-axis at 5. My slope is negative 2, so this is change in y over change in x. I'm going to go down 2, but the 1 is positive, so I'm going to go right 1. Put another point. Down 2, right 1, put another point. So I've got 3 points. and I can graph the line. Okay, so we converted and we use the slope-intercept form to graph. Let's look at another one. 4x minus y equals -1. Okay, I'm trying to isolate y, so I need to move this 4x. It's a positive 4x. I'm going to subtract 4x from both sides. I'm going to bring down a minus y. Don't lose that negative sign. I'm going to write my negative 4x term first and then the minus 1. This is a -1 times y, so I'm going to divide both sides by -1, and that means I have to divide every single term by -1. So I end up with y equals -4 over -1 is a positive 4x. -1 over -1 is plus 1. So y equals 4x plus 1. So my slope is 4 over 1. And my y-intercept is a positive 1. So on my y-axis, I put a point at 1, and then I graph. This is a positive 4, so I'm going to go up 4, and a positive 1, so I'm going to go right 1. I can fit 1 there. You can go backwards if you want to. And, oh, and I was doing so well. There's my line, okay? Always check. This had negative slope. The line I drew has negative slope. This has positive slope. The line I drew has positive slope. Next example, -3x plus 2y equals 8. So, trying to isolate y, so I have to move this minus 3x. I'm going to add 3x to both sides. I bring down the 2y. I write the 3x first and then plus 8. Those are not like terms, so I cannot combine them. This is 2 times y, so I'm going to divide every single term by 2. These 2's cancel, they become 1. Y equals, and write this as a fraction. So this is 3 halves x plus 8 over 2 is 4. Okay, so you identify M and you identify B. The slope is 3 halves. The y-intercept is 4. Now I want you to graph this line. Graph the line that has a slope of 3 halves and a y-intercept of 4. So there's my y-intercept of 4. Notice I did not have room to go up 3 and right 2. I was out of room, right? So remember, if you're out of room and you're about to go off the graph, reverse it. So instead of up 3 and right 2, I went down 3 and back 2. Notice the line I drew has positive slope. I should have had a positive slope. Let's convert another one. X plus 3y equals 9. So I'm trying to isolate the y. I need to move this plus x. So I'm going to subtract x from both sides. And I get 3y equals -x plus 9. Now I need to divide every single thing by 3. Every single term. So these 3's simplify to 1. So y equals, now right here, this is kind of weird, but you know that there's a 1 there. So my coefficient is -1/3, then x, and 9 over 3 is 3. Okay, you identify M and identify B. The slope is -1/3. The y-intercept is 3. Now you graph the line. Make sure your line has negative slope. I ran out of room going down and right, so to get my third point, I went up and left. Everything lined up, and there's the line. "3x minus 5y equals 20." So I want you to take this linear equation that's in standard form. I want you to convert it to slope-intercept form. You should have gotten y equals 3/5 x minus 4. If you didn't, correct your work. Once you have everything correct, identify M, identify B, and graph the line. There was only room on this graph for 2 points, so my y-intercept's -4, and then my slope is +3 over +5. I drew a line with positive slope. I had positive slope. One more. 3x minus y equals 1. Convert this equation into slope-intercept form. You should have gotten y equals 3x minus 1. If you didn't, correct your work. Make sure you have it right. Now, identify M, identify B, and graph. So there's the line. Make any corrections you need to make, and now you're ready to practice.